Dear data enthusiasts, welcome back to my channel. Today, we're diving into the exciting world of data collection using two of the most popular programming languages, which are Python and R. Whether you are a data scientist, data analyst, or just a curious learner, this video will give you a solid understanding of how to collect data using both these powerful tools. So let's get started. We start developing our machine learning model when we collect data. But before, there is a lot of things to consider while collecting data. The primary goal during this phase is to identify and gather the necessary data for machine learning purposes. Here are 5 key considerations to bear in mind during data collection. Accuracy is paramount, especially for supervised machine learning, where historical data with outcome labels is used to train models. The precision for this data significantly impacts the model's success. Relevance is crucial. The data collected must directly relate to explaining the observations, label, or response. Quantity matters, as different machine learning algorithms require varying amounts of data to yield meaningful outcomes. Variability in collected data is essential to provide a diverse range of input for the model. And finally, ethical considerations such as privacy, security, informed consent, and bias are vital throughout the data collection process to ensure fair and unbiased model predictions. In summary, collected data for machine learning purposes should be accurate, relevant, abundant, varied, and gathered ethically to ensure the effectiveness and integrity of the model. Web scraping, on the other hand, is a technique for extracting data from websites. It involves fetching the web page content and parsing the HTML to extract the necessary information. Today, we'll be using a mock website called Books2Scrap, which is designed specifically for practicing web scraping. As we mentioned before, data collection is the initial step in bringing a machine learning model to life. If the data is not already available, data scientists are responsible for sourcing and scraping data, with web scrapers being a common method used. However, it's essential to approach web scraping responsibly, respecting the website terms of service and ensuring compliance with legal and ethical standards. Now, let's get started with coding. When it comes to web scraping using Python, there are several libraries available for extracting data from HTML code, such as BeautifulSoup, Selenium, Scrappy, and more. In this tutorial, I will specifically delve to the BeautifulSoup library. If you are keen on learning about web scraping with Selenium or Scrappy, feel free to leave a comment below. I will be happy to create a detailed tutorial for you. Before we start, we can check out the documentation of BeautifulSoup library to explore the various methods and functions. First, we can start by installing the libraries we will be using in this tutorial. We use pip3 command to install libraries in Python. All the packages are listed in the requirement file. You can simply install all the packages with one command, pip3 install -r requirement.txt. Using requirement.txt file is a best practice in Python project, especially for ensuring that the development and production environments are consistent and easy to set up. Now we have our packages installed and ready to use. The next step is to import the packages to start scraping data. So we first import requests. Requests library is a simple and elegant HTTP library for Python. It allows us to send requests to HTTP. We will mostly be sending GET requests to retrieve HTML code. The second package we import is BeautifulSoup. So this is our champion. It's the tool that will make it easy for us to scrap information from the web pages. It creates a parse tree from page source code that can be used to extract data easily. Then there is Pandas, which is the genie for data manipulation and analysis library for Python. It will be providing us with data structures like series and data frames designed to handle data easily and efficiently. So what we will do in this tutorial is make an HTTP request to fetch a web page using request, parse the HTML code using BeautifulSoup, extract and clean the data, then load it into Pandas data frame. Let's run this. After we imported the packages, we define the URL of the page we are willing to scrap. Here we have the Books2Scrap website. It's a simple e-commerce site listing various books with details like titles, prices, and availability. We will be using this website to demonstrate how to scrap data. So we'll copy the URL and paste it. Next, we will use the get method to make a request and fetch the HTML code. Now, if we use print to see what is stored inside the response variable, we will see that it says response 200. The response object returned by requests library when you make a request to a web server. It contains all the information that the server sends back in response. It includes status code, headers, content, and other metadata. The 200 is the status code, which indicate that the request was successful. Other status code can be 404, which means not found, 500, which means internal server error, and 403 forbidden, which means the server understood the request, but it refuses to authorize. So if you want to access the status code, we'll use response.statuscode. If you want to access the header returned by the server, we use response.head. Now we need to parse the HTML code using BeautifulSoup. This is a class from BS4 module. We use BeautifulSoup for parsing HTML and XML logic. It creates a parse tree from the HTML code, which will allow us to easily navigate and search through the HTML structure. The first argument is response.content, which is the content you want to parse. In the second argument, we specify the parser we want to use for processing the HTML content, which is in our case HTML.parser. Other parsers you can use are LXML, a faster parser that supports XML, and HTML5 lib, a parser that follows HTML5 specification, useful for handling poor formatted HTML. We call this object soup, and for the rest of this tutorial, soup will allow us to navigate easily, search, and extract data from the HTML document. Now we want to scrap the book's title, price, availability, and the rating. Let's find out how to do this. So here we have the list of books. We need to find what type of HTML tag we need to select from the code we retrieved into Python. To do this, we left click on the book area, we choose inspect element, and you can see that books are listed in li tags. And inside we have article tag with the class product pod. So this is how we select these books using BeautifulSoup. Books equal soup dot find all. Article class is product pod. We use find all method to search through the parsed HTML document soup for all elements that match the given criteria. The first argument we use is article, which is the name of the tag that we are interested in. Then we continue our search criteria by specifying that we are looking for article tag with the class product pod. Note that we use class underscore, not simply class, because the word class is a reserved keyword in Python. Now, what if we want to select a tag with an ID instead of a class? You can simply use ID equals prod pod. We can also use attributes argument where we identify the parameters using a dictionary. Now, if you print the value book, you will see a list of HTML code that contains the books on the web page. Each item on the list is a BeautifulSoup object representing an article element. So now we can further process each of these objects to extract more specific data. So first we initialize what we want to collect: title, prices, availabilities, and ratings. These lists will store the data extracted from the HTML for each book. Next, we use a for loop to iterate over each item in the book's list. We will start with the title. If we go into the HTML code, you will see that the title is on h3 tag. You can either use book find h3 and then find a and get title, and we get the name of the title, or we simply do find h3 and we can either say .text or get text. It's up to you. Now what we will do is append this value into the list of books. Next, we want to extract the price of the book, so we simply go back, inspect element, to find the tree to the price. So you see that it's under a div with the class product price and a b paragraph tag with the class price color. So let's tell BeautifulSoup how to get the price. It's books.find b with the class And there you have it, the price of the first book. So we simply going to copy this here and append it to the list. Similarly, the availability is a paragraph tag with the class in stock availability. So we just copy this. Append it to the list, and before we can even check if this gives us the right text, and there you have it, it's in stock. Now for the review rate, things are a little, the rate is in a paragraph, or let's say the first paragraph tag, and the class change with the rating of the book. So for a 2 star, we have the class star rating 2. For the 3 stars, we have the name of the class star rating 3. So by default, when we ask BeautifulSoup to find a tag name B, knowing that there are multiple tags with the same name, it extracts the first one with 5. So we do ratings.band.find the first paragraph. And here, instead of selecting the text or using the class name to extract a specific tag, we will actually extract the name of the class of the first B tag. So we do as follows. You can check the results first, and you see that it returns the rating. But since it returns a list where the actual rating is in the second position, all is left for us to do is to retrieve the second value in the list. And there we have it. We extracted all the information on books on the first page. Now what we will do is merging all these lists into one data frame as follows. And if we do print the df after running the code, see that we have the first 20 books on the web page. Now let's say you want to go scrap data page by page until the last one to get all the books on the website. How do you do this? Yes, you go to the end of the website, you will find that this page actually represents page 1 of 50 pages. You can use this information to start looping over pages, or as I recommend, collect this information so that you can automatically run your web scrapper without checking if there are more data or pages added. So as you know it by now, we do inspect element, we see the name of the tag and the class, we go back to our coding environment, we specify that we want to get the lead tag with the class current. Let's print this out. So we want to get the number 50. We need to tell Python how to do this. We split the value final. We get the last part and convert it into a number using int method. We print it to make sure it works, and there you have it. Now let's go back to our website to see how it navigates from page to another. Here we have it, the next page, where the URL adds the value page 2. So let's do the same using Python. Here we have our URL, but we want to navigate pages from 2 to 50. Therefore, we will use a loop that goes from 2 to 51. And we will change the number of the page on the URL with I to keep navigating the website and scrapping books on pages. So now we can simply copy the code as before. Seeing that all pages have the same structure. Let's run this code and wait for it to end. Let's redefine the date frame to include all the book scraps. As you can see now, we have 100 rows with no missing data. So this code effectively scraps books data by navigating into each book HTML and extracting title, availability, price, and rating. Next, let's find out how we can scrap data using R.